Ship-to-ship collisions are often the result of a complex chain of events rather than a single mistake. Investigations frequently point to human error, miscommunication, equipment failure, or a breakdown in navigational procedures. In some cases, captains and officers rely heavily on radar and automated systems, assuming that modern technology will compensate for reduced visibility or fatigue. But as accident reports have shown, over-reliance on instruments can dull situational awareness, especially when weather conditions deteriorate rapidly. Severe weather remains one of the most formidable challenges at sea. Storms, cyclones, and heavy fog can reduce visibility to near zero, distort radar readings, and generate waves powerful enough to push even large vessels off course. When two ships attempt to navigate the same stretch of water during a storm, the margin for error narrows dramatically. Strong winds may alter a vessel's heading, while heavy swells can impair steering. In such conditions, even experienced crews can struggle to maintain control. Climate scientists have warned that extreme weather events are becoming more frequent and intense. The World Meteorological Organization has reported a rise in severe storms linked to climate change, increasing the risks faced by seafarers. Ports may close during cyclones, forcing ships to anchor offshore in rough seas. Anchors can drag, vessels can drift, and collisions may occur before crews have time to react. In narrow channels or crowded anchorages, the danger multiplies. Maintenance failures are another critical factor in maritime accidents. Ships operate in corrosive saltwater environments, where metal fatigues and mechanical systems endure constant strain. If routine inspections are delayed or cost-cutting measures reduce the quality of repairs, small defects can escalate into major failures. A malfunctioning steering system, worn propeller shaft, or faulty navigation light can contribute directly to a collision. When watertight doors fail or hull plates weaken, the risk of sinking increases significantly after impact. In some high-profile incidents, investigators have found that safety systems were not fully operational. Fire suppression equipment may have been outdated, emergency generators poorly maintained, or life-saving appliances insufficient for the number of passengers on board. Such shortcomings can transform an accident into a tragedy. Survivors often recount confusion during evacuations, with crew members struggling to coordinate lifeboat launches in heavy seas. The consequences of maritime collisions extend far beyond the vessels involved. Oil spills from damaged tankers can devastate marine ecosystems and coastal communities. Fisheries may be closed for months, and tourism can suffer long-term damage. Cleanup operations are costly and complex, requiring coordination between governments, environmental agencies, and shipping companies. In heavily trafficked waters, a single accident can disrupt supply chains, delaying the delivery of essential goods. Investigative bodies play a crucial role in understanding what went wrong. National maritime authorities typically conduct inquiries, but the IMO sets global safety standards through conventions such as the Safety of Life at Sea, SALAS. These regulations mandate regular inspections, crew training, and the installation of modern navigation equipment, including the automatic identification system, which allows ships to track one another's positions. While compliance has improved over the years, enforcement varies between countries. Human factors remain central to most accidents. Fatigue is a persistent problem in the shipping industry, where long voyages and tight schedules can strain crews. Officers may stand watch for extended periods, particularly on smaller vessels with limited staffing. Communication barriers can also arise on ships with multinational crews, where language differences complicate the interpretation of navigational instructions. In high-pressure situations, misunderstandings can prove fatal. Training and simulation have become increasingly important tools in accident prevention. Modern maritime academies use advanced bridge simulators to recreate storm conditions, equipment failures, and collision scenarios. By practicing emergency responses in controlled environments,